factoring trinomials. And specifically, we'll be factoring trinomials of the form x squared plus bx plus c. So by the end of this lesson, you should be able to factor quadratic trinomials of the form x squared plus bx plus c. Remember, quadratic means that our highest exponent in any term is a squared, and trinomial means 3 terms. So first, let's review. We wanted to FOIL or double distribute, which you probably haven't heard me use that term. A double distribute just means everything in the first parentheses gets multiplied by everything in the back. So when we FOIL, we do x times x because that's the firsts, so that's x squared. Then we do the outside terms, x times 6, so that's 6x. We do the inside terms, x times 4, or 4x. And we do the last terms, 4 times 6, which is 24. And what we always want to make sure that we do is combine our like terms. So we end up with x squared plus 10x plus 24. What we're going to be doing today is essentially the opposite of the FOIL method. We're going to be starting here with the trinomial, and we're going to be working backwards to factor it. So I do need you to write these steps down, but when we factor trinomials, it's basically, again, the opposite of FOILing or double distributing. So there's the method of guess and check, and that essentially could take forever, especially if you're not sure what you're looking for. So we like to use method 2. Method 2 says when you factor a quadratic trinomial of the form x squared plus bx plus c, you're looking for 2 factors of c, so that's the constant in the back, whose sum is b. And so this is the really important part. You're finding 2 factors of c whose sum is b. So factors of the constant that add up to the coefficient in front of the x. Then 2 other important pieces to remember is that if the c is positive, the factors are going to have the same sign, and they'll match the sign on b. The other option is c is negative, and when c is negative, the factors are going to have opposite signs. So one will be positive and one will be negative. So we're going to just start looking at some examples. There are several examples here, and I'll probably stop a little short and let you work the last few out on your own. And then those will be what I'm checking when I check your notes. So when we factor an expression, a trinomial breaks down into 2 smaller binomials. So I always draw my parentheses first. What's nice about today is that every first term in our trinomial is going to be a simple x squared with no coefficient in front. If I factor an x squared, it factors into x and x. So I know that the beginning of my binomials in my factored form are going to both have x's in the front. That's because when I do the FOIL method to get back to my original problem, x times x is x squared. Now we can talk about signs a little bit now, but I am going to wait until we actually put our factors in. Remember what we're looking for. Factors of 10 that add to 7. So the factors of 10 are 1 and 10 and 2 and 5. So which of those 2 factors add up to 7? And hopefully you're saying 2 and 5. What's nice here also is that for the most part today, it's not going to matter which factor you put where. So I'll put the 2 first and the 5 second. So I have x, and it's either going to be a plus or minus 2 times an x with a plus or minus 5. And if we go back and look at what it stated before, it said when c is positive, the factors are going to have the same sign, so they're either both positive or both negative, and they're going to match b. So if we look at what b is positive, so these both need to be positive. And hopefully that makes sense to you, because when we do FOIL this back out, you get 2x and you get a 5x. They're both positive, so when you add them, that does give you 7x, which is what you want for your middle term. I know that the first two terms are going to give me x squared. I know that the last two terms are going to give me 10. So when we go back and check our answer here, you'll typically only see me checking the outside and the inside terms from FOIL. That's all I will check. So this is your factored expression. X squared plus 7x plus 10 factors into x plus 2 times x plus 5. Again, if we completely FOILed that back out, we would get x squared plus 7x plus 10. X times x is x squared. My outside term is 5x. My inside term is 2x. And my last term is 10. Again, combining like terms, you get x squared plus 7x plus 10. You get exactly what you started with in your problem. So let's kind of erase some of these lines everywhere. This is your answer. This was just my check. And you're more than welcome to check, or you can do what I had done a moment ago and just check the inside and outside terms. Let's look at another example. Here we have n squared plus 21n plus 20. So again, a trinomial, a quadratic trinomial, is going to factor into two smaller binomials. And we know that because it's just n squared factors into n times n. So I know I need that in the front. Again, we're looking for factors of 20 that are going to add up to 21. If it helps you initially to list the factors of 20, you are more than welcome to do that. So the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. And I'm looking for factors here that are going to add up to 21. And hopefully you see that that's 1 and 20. Again, it doesn't matter which factor you put where in the back, but it's going to be 1 and 20 for me. You could put the 20 first and then the 1. We need to determine what signs. Again, the back is positive, which means our signs are going to stay the same, and they're going to match the middle sign. So they're both positive. We need a positive 21. If I check my inside and my outside terms, I get 1n and 20n, and when I add those together, 1n plus 20n is 21n. So I know I got the correct middle term. I know that my expression is factored correctly, so the correct answer here is n plus 1 times n plus 20. And it looks like I skipped a number 1, so we're on technically number 3, but I've got it labeled as number 4. So factor this expression, n squared plus 13n plus 30. So again, we're going to break it up into two separate binomials. We're going to put n in the front of both binomials. And now we're looking for factors of 30 that add up to 13. So 1 and 30. We have 2 and 15. We have 3 and 10. 4, 5, and 6. And so if we're looking at which ones add up to the middle, that's going to be the 3 and the 10. So I'll put the 3 in the front, the 10 in the back. Again, my C is positive, so that means the signs in the parentheses are going to be the same, and they're going to match the middle, so they are both positive. This inside term gives me a 3n when I multiply. This outside term gives me a 10n, so when I add those up, it's 13n. And again, all I'm doing here is just checking to make sure that if I were to FOIL this back out, my two inside and outside terms would add back to 13n. If you were to not get 13n here, it means you have something incorrect, either the wrong factors, possibly the wrong signs. So now we've done several examples that had two positives. Now let's look at an example where our middle term is negative. And what I want to make sure you're understanding is that this does not necessarily mean right away that the signs in the parentheses are negative. It also doesn't necessarily mean that because you see one of each, that you should have one of each. Okay, there are rules to determining how we get our signs. Again, p squared, so I need a p and a p in the front. I'm looking for factors of 25 that are going to give me a 10. Well, that's 1 and 25, or 5 and 5. Well, 1 plus 25, that's 26. 5 and 5 is 10. So I know those are the factors I want in the backs. So 5 times 5. That's going to give me that 25 for my last term. But now we have to talk about the signs, and this is where it's a little different than the first few examples. We have a positive 25. Remember, a positive C means that the signs are the same. So if you have a positive C, signs are the same, and they match the B. Well, this is my B, and my B now is negative. So that means they're both subtraction signs. Watch what happens when we find our inside and our outside terms. This is a negative 5p. This is a negative 5p. And when I add those together, I get negative 10p. So that is my middle term, so I know that I have it factored correctly. P minus 5 times P minus 5. Example 6, we have g squared minus 11g plus 18. So again, now I'm splitting it up into two smaller binomials. I'm putting g's in the front automatically. G squared factored is g times g. I'm looking for factors of 18 that are going to give me 11. Well, that's 1 and 18, 2 and 9, 3 and 6. The 2 and 9 are going to give me an 11, so I can put 2 in the back of one parenthesis and 9 in the back of the other. They do not need to be in that particular order. You could have the 9 first and the 2 second. Again, our back number is positive. Because the back number is positive, our signs are the same, and it's going to match this guy in the middle. So it's a minus 2 and a minus 9. You can see that gives you minus 2g and minus 9g. When I add those up, that's negative or minus 11g. So I know I have it factored correctly. G minus 2 times g minus 9. Go ahead and try example 7 on your own. So pause the video. We have m squared minus 15m plus 36. See if you can come up with the correct answer. We split this into two smaller binomials, m times m, so m's in the front. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So the factors that are going to give you 15 are here in the middle, this 3 and 12. So 3 and 12. Because the back sign is a positive, it matches the middle. They are the same, both subtraction. This gives you a negative or minus 3m. The outside terms give you a negative or a minus 12m. Negative 3 and negative 12 is negative 15m. So I do get this middle term back. Remember, when I'm doing this method, this is just a check. This is not actually a step to the problem. Some of you are going to be able to do this part in your head, and that's fine, but I'm just checking to make sure that if I foiled that back, I got my problem. When you foil your answer back, you must get the original problem or you didn't do it correctly. Number 8 is a little different because now we have a negative sign in the back. So let's go back to one of those first slides, and let's see how that's going to change things. Here it says when C is negative, the factors are going to have opposite signs. So now in our parentheses, we're going to have a positive and a negative. So again, we want to split this up. Two binomials, x in the front and x in the front. And I want a positive and a negative. I'm not sure if they're in the right spot just yet, but we're going to go ahead and find our factors first and then check if they're in the correct spot. So we're still looking for factors of 20 that are going to give us an 8. So we have 1 and 20, 2 and 10, 4 and 5. And now you're probably looking and saying, okay, that gives me 21, that gives me 12, and that gives me 9. Well, none of these give us 8. But the difference here now is we have addition and subtraction. So now you're looking for the difference. Which of these factors, when you subtract them, are going to give you an 8? And hopefully you're saying 2 and 10. And you can think of this in a couple different ways. We have 10 minus 2, and we have 2 minus 10. Well, 10 minus 2 is positive 8, and 2 minus 10 is negative 8. Well, which one do we want? You should be looking here and seeing that you want a positive 8. So this This 10 and negative 2 is what we want. That means the 10 needs to be positive and the 2 needs to be negative. Now when we do our inside, we get 10x. When we do our outside, we get a minus or a negative 2x. And when you add those up, that gives you this positive 8x here in the middle. So you know you have it factored correctly. So when your signs are the same, you can still think of it as finding factors of the back number that add up to the middle, except now because one of our factors is negative, it's more like subtraction. So number 9, we have n squared minus 3n minus 40. So that's going to be an n and an n. And again, we have one of each sign. And that's because this back term, that 40, is negative. It's subtraction, so we have one of each. So let's list the factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. We know that we need a negative or a minus 3n because we have one positive and one negative. Now you're thinking about subtracting these factors. Which one gives you 3? This one gives you the 3. So you have 8 minus 5, or you have 5 minus 8. 8 minus 5 is positive 3. 5 minus 8 is negative 3. This is the one we want because we need a negative 3n in the middle. That means your 5 needs to be positive and your 8 needs to be negative. That's positive 5n. Oops, I put an X. And negative 8n. And when I add those up, I get negative 3n. So I know I have it factored correctly, n plus 5, n minus 8. Now you go ahead and try number 10 on your own. This is one again where the back term is negative, so make sure that you have the correct signs inside your parentheses. Once you're finished, please check your answer with mine. Factoring the trinomial into two binomials, so it's b and b in the front. And now I need factors of 56. That's 2 and 28, 3, 4, 5, 6, 7, and 8. I think those are the only factors of 56. Maybe 4 and 14. Did I skip one? Yeah. And 7 and 8. And we're trying to get, remember this is a 1, a negative 1b in the middle. Think about your signs first. Because the back term is negative, we get one of each. And we want to get a negative 1. So because we want to get a negative 1, I'm looking for the factors that when I subtract give me that negative 1. And hopefully you're seeing 7 and 8. Some of you now are going to be able to recognize right away it should be a positive 7 and a negative 8 because we want to get a negative 1 in the middle. So this gives you a 7b, the outside gives you negative 8b, and when you combine those two terms, you get the negative 1b or the negative b. So b plus 7 times b minus 8. Okay, there are a total of 16 examples in this lesson, and what I'm going to do here is I'm going to stop walking you through them, and I want you to try to solve these, factor these on your own. What we'll do in class is we will check the 6 answers, and if you have them correct and you feel confident, then we'll go on and work on the worksheet. If not, we can take some more time to talk about how to factor trinomials. So number 11 is m squared plus 8m plus 15. So write that down because I'm going to go on now and read you 12 through 16. Number 12, we have x squared minus 9x plus 20. 13, y squared plus 13y minus 48. 14 is x squared plus 2x minus 48. 15 is m squared minus 17m minus 60. 16 is d squared plus 17d minus 60. So again, you do need to solve 11 through 16. Try to factor all of those expressions, paying very close attention to the signs inside your parentheses, making sure that you get that middle term exactly right when you're factoring. And in order to get the credit for your notes, you're going to have 11 through 16 already completed before I check your notebook. In class, we will work on worksheet 8.3.